Right, okay. So we are going to do a example question of velocity and displacement time graphs. I'm going to have a quick discussion about what all of the points on this graph mean. So, question reads, a boy throws a ball vertically upwards and lets it fall to the ground. Figure 1 shows how displacement relative to the ground varies with time for the ball. So, the first thing to notice is that at t0, at the beginning, time equals 0. The displacement from the ground is not at ground level. And the reason for that is because the boy's got the ball in his hand. So we just need to note that. It says the boy throws the ball vertically upwards. So this means that the ball is going upwards, displacing away from the ground all the way until a certain point. Part A, the question, state which feature of a displacement time graph represents the velocity. Well, that has to be an immediate answer, like you need to know that one, so that is the gradient. So, on the axes below, draw the shape of the velocity time graph for the ball between t0 and t2. So that's t0 and t2. We have a nice convenient point here, t1 as well. Draw the shape of the velocity time graph for the ball between those points, and the starting point is labelled x. So this basically gives us some positive velocity, meaning that it's heading upwards. First convenient point on the displacement time graph is at t1. Now, if I draw a tangent to the curve there, on this graph, that is a flat line, meaning that velocity there is 0. Displacement is not changing with time at that point, so velocity is 0. So I know at time equals 1, velocity is going to be 0. So I can mark that on my graph as a point to draw. Then, I need to have a think about what happens after t1, so in this part. So if our gradient is positive here, that means a positive velocity, that means it's going away from our point, so upwards away from the ground. Here we've got a negative gradient, meaning that our velocity is going to work out as a negative, which means that on this graph it's going to have to come below 0. And to figure out exactly sort of where it comes in, what we've got to think about is the acceleration. So in order to draw this line accurately, I need to know the gradient of it. Does it curve? Is it flat? How steep is it? I've got to ask myself those questions. Now, luckily I know the acceleration in this case. It's that thing that we are never given, but always know in a projectile motion question, which effectively this is. I know that acceleration is always g. It's always negative 9.81 meters per second. So accelerating downwards at 9.81 meters per second. That means that the acceleration, the gradient of this line is going to be constant, which means that I can draw a straight line. And I already have 2 points. So I can put my ruler on those 2 points like that and draw the line in like so. And that would be the velocity time graph for this curve. So, positive but decreasing velocity on the way up, 0 velocity at time equals 1, where the tangent to the line is flat, and then negative and increasing velocity after time is 1 up until time equals 2, t2, when it hits the ground. So those are the kind of things that you've got to be, that's the thought processes that you've got to be going through to answer this kind of question.